The concept of the skyscraper originated in the late 19th century in the United States, as burgeoning cities like Chicago and New York faced a scarcity of land and a surge in population. The development of steel frame construction, coupled with the invention of the elevator, made it possible to build structures that soared far above previous limits. The Home Insurance Building in Chicago, completed in 1885, is often considered the first skyscraper, standing at 10 stories tall, a marvel of its time that paved the way for the modern skylines we see today. The process of building a skyscraper. Every skyscraper begins as an idea. Architects and developers collaborate to conceptualize a design that is both aesthetically pleasing and functional. The purpose of the skyscraper, whether commercial, residential, or mixed use, will influence its design and features. During this stage, the architect drafts preliminary sketches, and engineers assess the feasibility of the structure. Once the concept is clear, the project enters the planning phase. This involves extensive research into local building codes, environmental impact assessments, and securing permits. The site location is also crucial, requiring geotechnical surveys to understand the soil and subsoil conditions. These surveys inform the foundation design, as different ground conditions can significantly affect the building's stability. 2. Site preparation and excavation. After all the necessary approvals are obtained, site preparation begins. This involves clearing the site of any existing structures, vegetation, or debris. If the skyscraper is to be built in a densely populated area, this can be a complex process, requiring careful coordination to minimize disruption to surrounding buildings and infrastructure. Excavation is the next critical step, where the foundation of the skyscraper will be laid. Depending on the height and design of the building, the foundation can be quite deep, sometimes requiring excavation down to bedrock. This stage often involves the use of heavy machinery like bulldozers, excavators, and cranes. During excavation, retaining walls might be constructed to prevent soil collapse, ensuring the site remains safe for workers. 3. Foundation construction. The foundation is the most crucial part of the skyscraper, as it supports the entire structure. There are different types of foundations, such as mat foundations, pile foundations, or caissons, depending on the soil conditions and the building's weight. For very tall skyscrapers, deep foundations are essential to anchor the building securely to the ground. In many cases, reinforced concrete is used for the foundation, combining the compressive strength of concrete with the tensile strength of steel. The construction of the foundation involves pouring large quantities of concrete, often requiring continuous pouring over several days to ensure structural integrity. This phase is meticulously planned and executed, as any flaws in the foundation could compromise the entire building. 4. Steel framework erection. Once the foundation is complete, the erection of the steel framework begins. This is where the skyscraper starts to rise from the ground. Steel beams and columns are brought to the site, often prefabricated to specific dimensions. These steel components are then assembled like a giant 3D puzzle, with cranes lifting the beams into place, where they are bolted or welded together. The steel framework serves as the skeleton of the skyscraper, providing both vertical and lateral support. Workers, often operating at dizzying heights, must connect the steel beams with precision, following the architectural design to ensure the building's shape and stability. This phase is usually carried out floor by floor, with each completed level providing a platform for the next. 5. Flooring and decking. With the steel framework in place, the next step is installing the floors. Flooring typically consists of metal decking, which is laid across the steel beams and secured in place. Concrete is then poured over the decking to create a solid floor surface. This process is repeated for each level of the skyscraper, creating a series of sturdy, load-bearing floors. At this stage, the building begins to take shape internally. Stairs and elevator shafts are constructed, providing access between floors. The placement of these elements is crucial, as they must align perfectly with the architectural plans to ensure the building's functionality and safety. 6. Facade installation. The facade is the exterior skin of the skyscraper, often the most visible and defining feature of the building. Facades can be made from various materials, including glass, steel, aluminum, or stone. The choice of material depends on the architectural design, energy efficiency considerations, and the building's location. The installation of the facade is a complex process that often involves lifting large, prefabricated panels into place. These panels are attached to the steel framework, forming the exterior walls of the skyscraper. The facade must be both weather-resistant and aesthetically pleasing, as it protects the building from the elements while contributing to its visual impact. 7. Mechanical, electrical, and plumbing (MEP) systems. While the exterior is being completed, work on the building's internal systems begins. The mechanical, electrical, and plumbing (MEP) systems are essential for the skyscraper's functionality and comfort. These systems include heating, ventilation, air conditioning, HVAC, electrical wiring, water supply, and waste management. The installation of MEP systems is a highly coordinated effort involving multiple trades. Ductwork, piping, and electrical conduits are installed within the walls, ceilings, and floors, often requiring precise routing to avoid conflicts. Advanced systems, such as energy-efficient HVAC units and smart building technology, are also integrated during this stage. 8. Interior finishing. Once the MEP systems are in place, the interior finishing work begins. This phase includes installing walls, ceilings, flooring, and fixtures. Drywall is used to create interior partitions, while ceilings are finished with tiles or other materials. Flooring options might include carpet, tile, or wood, depending on the building's purpose and design aesthetic. Interior finishing also involves painting, installing lighting fixtures, and fitting out bathrooms and kitchens if applicable. The goal is to create a polished, functional interior that meets the design specifications and the needs of future occupants. Before the skyscraper can be opened to the public, it must undergo a series of inspections and tests to ensure it meets all safety and building code requirements. Any issues identified during these inspections must be addressed before the building can be occupied.